Good day, grade 12 learners. Welcome to today's geography lesson. My name is Rina van Heerden, and this lesson is brought to you by the Gauteng Department of Education in collaboration with Saibono Discovery Centre, and it is broadcast by Pakama Research and Development. You are more than welcome to send a WhatsApp message to the following number if you have any questions on the content that will be discussed. The number is 063 629 3655. I'm going to repeat it. 063 629 3655. Let's start. Today's lesson is about climatology. It's the last lesson on climatology, and the content that we're going to discuss is valley and urban climate. At the end of the lesson, you will have a better understanding of the following. Valley climate, we're going to look at slope aspect, the definition and the effect. We're going to look at the definition and development of anabatic winds, katabatic winds, inversions. We're going to look at the thermal belt, the frost pocket, radiation fog, and the influence and impact on human activities. The human activities, we're going to look at economic, social, and environmental. And then the influence on settlement and farming. Okay, let's start. We're also going to look at urban climates. What are the reasons for the differences between rural and urban climates? We're going to look at the urban heat island. And when we look at this, we're going to look at the definition, what causes the urban heat island, what are the effects of the urban heat island, and strategies to reduce the urban heat island. Then we're also going to look at the pollution dome, the definition, the causes, the effect, and the strategies to reduce the pollution dome. So today we're going to start with valley climates. In valley climates, they refer to slope aspect. And this is not supposed to be a new term for all of you. Slope aspect are one of the topics that was discussed in grade 10. So when we refer to slope aspects, we're going to look at the following. What is it again? It is the orientation of the slope with regard to the position of the sun. Where is this slope in connection regarding the position of the sun? We're going to look at the southern hemisphere because the sun's position in the southern hemisphere is different than it is in the northern hemisphere. Because in the southern hemisphere, our north-facing slopes receives more direct sunlight. That means those are your more popular slopes in the southern hemisphere. The northern hemisphere, the opposite is happening. My south-facing slopes receives more direct sunlight. And here is a diagram for you to show you. I have the sun. Here's north. That's what you first need to look at. It's north. You first need to look at south. Now I see the sun is on this side, on the northern side, which means this slope that faces north is the warmer slope. So this picture that you can see here is definitely a slope in the southern hemisphere. And on the other side, my south-facing slope is my shadow zone. Okay, let's look at this. And this is now how we're going to draw. You must be able to draw this. There is my valley. I have the sun that is coming in And where does that sun sit? The sun is in the is from a northern angle, which means this slope over here is my north facing slope because this slope faces north. And this is my, on the other side, here's my south facing slope. So, this slope faces south and this slope faces north. And there's the sun from a northern angle. So what is happening here? This slope over here receives direct sunlight from the sun. See, my others will come in now. It receives direct rays of the sun. And the area that the sun here heats up is a smaller area that's being heated. It is therefore my warmer slope. On the other side, my south-facing slope only receives indirect sun rays from the sun. It's a larger area that's being heated, so that slope is cooler. And there you can see arrow-wise that my north-facing slope receives small area that receives direct sunlight. My south-facing slope, it's a larger area, which means it's a larger area that needs to be heated up. Okay, in winter, I'm now going to show you the difference of the angle of the sun in winter than in summer. So here you can see in winter, the angle, there it is, this angle at which the sun's rays come in from the north is actually very, that area here, the angle is more flat, more gentle. And therefore my shadow zone, the south-facing slope, they don't get any sun in winter. If they get, it's very less. So the big area where these sun rays must come in from. Now, if I compare that to summer, in summer, these sun rays come down further north, which means it's a bigger area that receives heat insulation from the sun. And that will influence farming activities, and it will influence human activity. Okay, I think it's the direction towards which a slope faces. The sun's rays come from the north, which is the direction of the equator. The sun's rays strike the north-facing slope, or the slope in the south-facing towards the north, at a more direct angle, what we saw just now. Therefore, my north-facing slopes in the southern hemisphere are warmer. Aspect plays no role in east-west orientation of valleys or slopes. Here, we only look at north and south. It's more noticeable during the winter months. Now, let's look at a typical exam question that you can expect on aspect. Study the diagram below and answer the following questions. Now, here is my diagram. First, we want you to look at the diagram and identify what is going on in this diagram. So, you see, you have to look at the key of your diagram. This key tells you that on this slope, now you also highlight, you take a highlighter. First of all, take a highlighter and you highlight your north and your south. so that you can see which slopes are where. Then I take my key and I see on this slope here, I have plantation. On this area here, those dots that I have there, those dots are houses, which means that people prefer to live here. And I have cultivated land, they want sunshine. So now you can use this diagram to orientate yourself. So this slope here where the plantation is faces south. This slope where the cultivated lands are faces north. Okay, let's see what are the questions on this. The first one is explain the concept aspect of slope. The second one is asking you in which hemisphere is this valley situated. And then number 3, they want you to provide a question for your answer. I am now going to give you 1 minute to study this diagram and to take a piece of paper and write down the answers on these 3 questions. And then after 1 minute, we're going to see if you are right or wrong. Okay, let's see what your answers are. There's my diagram again. The first question is to say what slope or what aspect is. Aspect is the direction towards which a slope faces. For that one, you can give yourself 2 marks because they ask likely a definition is 2 marks. Which hemisphere is this? Northern hemisphere. How do I know this? It is my sun's rays are from north. Yeah, sorry, boys and girls, that one is wrong. It must be southern hemisphere. Definitely southern hemisphere. And then the third one is you must give a reason. The cultivated land, this one here, which needs direct sunlight, is on the south slope, but it's facing north. The south-facing slope receives direct sunlight. Okay. Let's go to anabatic winds. That's the next topic. Anabatic winds, you need to know the definition and the development. Definition, it's an upslope movement of air from the bottom of the valley to the top of the mountain during the day. Now, you take your highlighters again. What is an anabatic wind? It's an upslope wind. You'll see I highlighted the important words. Where does it flow? It flows from the bottom to the top of the mountain. The other keyword is during the day. Upslope movement, bottom to the top during the day. It's a wind that blows during the day. So there's my valley. There's the sun's rays. It is day. There's our symbol knowing it is day. Therefore, the slopes warm up due to insolation. So these slopes will warm up during the day due to insolation. What does warm air do? Warm air rises. The air above the slopes warms up, it becomes lighter, and it rises up the slope. Let me show you. There's my warm air, it's red. It was heated. The air on the slopes was heated during the day due to insulation, and this warm air becomes lighted and it started rising. There's my air that starts rising. Eventually it cools down and it sinks again. And it's like a cycle of warm air rises, cool air that sinks. Okay, how does an anabatic wind develop? In the morning, air above the valley slopes heats up. Therefore, it's warmer on the slope than the air that is on the valley floor. On the valley floor, my air is cold, but the air above the valley slopes are warmer. The warm air rises, therefore I have upslope winds. Later during the day, the air on the valley floor also heats up, it's less dense, and it starts to rise. The pressure gradient force, and this is a grade 11 term. The pressure gradient force means I have a high pressure, I have a low pressure. Where air sinks, I have a high pressure. Where air rises, I've got a low pressure. So air moves from high to low. The pressure gradient force moving air from the high pressure at the lower end of the valley to the low pressure over the top of the valley. Okay. A katabatic wind. It's a downslope wind, cold air from the top of the mountain to the bottom of the mountain, and a katabatic wind occurs during the night. It's a downslope movement of air, downslope wind from the top of the mountain to the bottom. So this one is going down and it takes place during the night. Okay, there's my valley and there's the moon and the stars to tell you it is night. At night the slopes cool down due to terrestrial radiation. What does cold air do? The air above the slope becomes cold and dense. What does cold air do? It blows down the valley slide. So there's my cold air and it moves down the valley slopes. And the air at the bottom starts getting warmer, and they have been warm during the day. So those air, it goes up, it rises there, and it sinks again. Okay, how does it develop? Due to terrestrial radiation, air on the sides of the high slopes cools down, it becomes dense, and it flows down the valley slide. So, you're also supposed to know what is terrestrial radiation. It is discussed in grade 10. The air on the sides cools down, it becomes dense, and it flows down the valley slide. Later during the night, the air mass in the upper part of the valley cools. If the air cools down, it becomes dense, it becomes heavier and it starts flowing down the valley, like we saw in the previous slide. The flow is not fast. Frost and fog may develop in the hollows down the valley. Okay, an example of a question on valley climate. Okay, I've got two valleys. I've got valley A and I've got valley B. This is my valley floor, and there you can see your arrow. Now the first thing that you do is, if air rises, then it means this air is warm. Air that sinks is air that is cold. Now, from a previous paper, the following question will ask on this diagram. I'm going to give you also 1 minute to quickly read through each statement and decide if that specific statement belongs to figure A or figure B. So let's see how you can do this. When you are done with after the 1 minute, we're going to see how many of these answers you have correct. The 1 minute starts now. Okay, boys and girls, the 7 questions that we have is the air movement associated with upslope flow, the air movement that occurs during the night. So the night is my keyword here. Upslope is my keyword there. Air movement that originate due to the rate of insulation. Rate of insulation is my keyword here. Air movement that reduces air pollution. Where? At the bottom of the valley. So what am I busy doing? I'm now going to busy identifying the keywords here. Air movement associated with dense, heavy air. Air movement associated with the formation of frost in the valley floor. And then the direction of movement determined by gravitational forces. Gravity, ne? Okay, let's see what the answers are. Number 1's answer is A. Why? If I have these winds rising, this is anabatic wind. And at B I have katabatic wind. Okay, number 2 is B. Now, boys and girls, I didn't ask you to answer anabatic or katabatic. They asked you to answer A or B. A or B. 113 is A. 114 is A. 115 is B. 116 is B. And 117 is B. Now you can write yourself. And I hope that you all had 7 out of 7. Also coming from a previous paper. Now we come to inversion, the definition and development of inversion. Remember, now the past 2 slides, we looked at anabatic and katabatic wind definition and development. Now we are busy with inversion. First of all, what is the definition of an inversion? It is temperatures in the atmosphere which increase with an increase in altitude. Another word for altitude is height. Normally, remember, under normal conditions, temperature decreases with the increase in height. That means the higher you go, the colder it becomes. But with the inversion, it's just the opposite. If you climb this mountain, the higher you go, the warmer it becomes. If that happens, we have an inversion. So this is the definition. You'll see that the keywords are the words that were bold, which you can also bold when you study. Okay, I have my valley. I have a factory or an industry here at the bottom of the valley. Now I have air, that cold air that sinks down the valley. The cold air therefore collects in the valley of the bottom, at the bottom of the valley. So here you can see this blue area is where all this cold air that flows down the valley is collecting there at the bottom of the valley. But this factory is producing warm air. So what does this warm air do? This warm air rises there where the red arrow is. Therefore, that whole area from the factory to there, approximately there, is warm air. So what do I have here then? I have warmer air that forms an inversion layer. What is an inversion layer again? As I go higher, temperature increase instead of decrease. So, on the top of that, I have air that is on the higher ground, which are cool. It cools down by terrestrial radiation, and those air that cools with the increase in height. So here I have cold air, and here I have warm air, and there I have my cold air that collects in the bottom. So for this part here, where temperature are warmer, and it's supposed to be cooler because cold air becomes, the higher you go, the cooler it becomes. So this layer here is my inversion layer. How does it develop? Air is less dense higher up the slopes of the valley. Therefore, your higher levels of insulation during the day, we have higher levels of insulation during the day, and we have more radiation at night. The calm, cloudless winter nights with no strong winds that will mix the air, the upper slope air cools rapidly due to terrestrial radiation. The air becomes dense or heavy. It starts flowing down the slope to collect in the valley or in a depression or in a hollow. The cold air now replaces the warmer air on the valley floor. The warmer air rises to replace the cold air that move away from the high-lying areas. Therefore, a layer of warm air is trapped between the two layers of cold air, as we have seen in the previous diagram. Okay, there are 2 videos available on YouTube where they describe the scatterbatic winds and inversion, and I am going to show you those videos now.
This that I'm going to show you now is the basis of inversion. It's actually the basis of valley climates, especially during the evening. Now, what we've got here is that we've got here katabatic winds and inversions. Now you remember this is happening during the night, right? Now, easy to remember katabatic during the night. Cats walk during the night. Okay, here we go. So what happens is that the air has cooled off. And what happens when air cools off? It sinks down the valley slope. And we've got that. Look at our arrows here. The cold air sinks down the valley slope. Very, very important that you see that. Now, as it sinks down the valley slope, this warm air is being displaced upwards. Now, what's happening now? This means that here was warm air and here was cold air. But the cold air forced the warm air out. Now the warm air is on top and the cold air is at the bottom. But you know, you say, hang on. Isn't it that the higher I go, the colder you get? You're right. But we are dealing here with inversions. That is what. What is an inversion? An inversion is when the temperature increases with altitude. Let's just put it to you bluntly. The higher you go, the warmer it will get. Okay? So this means that here I'm going to get warm air instead of cold air because the cold air forced the warm air out. Okay? This means because it's so cold here at the bottom, I'm going to get a frost pocket there. I'm going to get smog there. And we're going to have huge problems for farmers because he won't be able to plant all his crops here. He will have to plant frost-resistant crops here. And those who are sensitive to crop to frost, he will have to plant there. Now, this is the basis of valley climates. Now, during the day, just the opposite happens. What happens? Your valley is being heated, right? And what happens today? It rises up the slope, and then you get an anabatic effect. But these ones that we're talking about here, these ones are the ones that usually tested because of the big influence it has on humans and the settlements. Okay, let's have a look now. Now, you must remember that this air, as it moves down the slope, then it means there was a high pressure on the slope, and here in the valley was a low pressure because winds or air always moves from a high pressure towards a low pressure. Now, this forms the basis of this exam question. And this exam question is very, very important. Last year, here's the question. Study the diagram on valley climates, and I must answer the questions that follow. Let's have a look at this. Name the wind 1 in sketch A. Here's sketch A, the wind 1. Right. Now remember, it can only be one of two, the katabatic or the anabatic one. So, that's it. So we've got the anabatic one here in the day, and the katabatic one during the night that we've got there. Okay. Now, the second question, state one difference between the winds 1 and 2. See, there's winds blowing there, and these winds 2 blowing there. Right, what's the difference between them? Here we've got it. Firstly, the one occurs during the day, this one, am I right? And this one occurs during the night. First difference. Second difference, what we've got here is that this one is occurs because of heating. In other words, warm air that rises. This one has to do with cold air that sinks. Another difference between the two. Another difference between the two would be that this one, wind blows from the valley upwards, and this one blows down the slope. Okay, so those are the differences between these winds that we've got. Now, here we've got, would wind 1 or 2 originate if a higher pressure occurred at the top of valley? Which one of these two would occur when the higher pressure is at the top of the valley? Remember what we have learned in grade 11. We have learned that winds always blow from a high pressure to a low pressure. Remember that. Okay. So the question says, where would wind 1 or 2 originate if a higher pressure was at the top of the valley slope? Now, let's have a look. Top of the valley. So this means that's it. Winds always blow from a high pressure to a low pressure. Look at my arrows there. Okay? That's very important. And the reason, therefore, is that the wind blows from the high pressure to the low pressure. Very important that you should know that. Okay. This one, actually, the students didn't answer this one very well. Explain why visibility on the valley floor, this here at 3 at the bottom, is less on winter mornings. Draw a label diagram to support your answer. Remember what I said about diagrams? Very important. So, Why is visibility less? Visibility is less because we've got a lot of smoke and pollutants here. What's happening? This is happening. The cold air rolls down the valley. Here we've got it, right? And the inversion traps the smog here at the bottom, right? And the result is that you have poor visibility. Now, you had to, the matrix last year had to supply a diagram as well. Can you see where the diagrams come in? Why it's so important? They would have got 2 marks for the direction, and they would have got 2 marks if they indicated the correct place where smog has been formed. Matrix, do you see why I'm saying your diagrams are so very, very important? Okay? So please practice your diagrams. These are easy marks, people, okay? And see that you really can get the maximum marks when you write your exams or tests.
Okay, I'm going to show you. There's another easier way of how to understand these inversions, and I'm going to ask you to look at this video as well.
Yeah, thanks, Rich. Yeah, we're going to talk about what a temperature inversion is. We're actually going to demonstrate what an inversion is using just different color or different temperature of water. Now, what is a temperature inversion? It's when the air actually gets warmer as you get higher up. This is a strong inversion right here. This is out towards the Leavenworth area. You can see the cold, more dense air sinking into the valleys. And in the meantime, up in the mountains, it's nice and sunny. So what's exactly taking place? Well, we're going to show you. This is our warm air. It's actually just warmer water. I actually just heated it up a little bit. And what we're going to do is we're going to add some colder air, colder water, and we're going to see what happens. Now, what do you think is going to happen when I pour this colder water inside right here? Is it going to mix right away, or what's going to happen? Let's take a look. I'm going to pour it in slowly, and just kind of keep your eye on the bottom of the tube and watch and see what happens. When this temperature inversion develops, we tend to get really stagnant air. The air just doesn't move very much, and you can see all the pollutants, all the car exhaust and smoke from chimneys. It just gets trapped near the surface, and we kind of end up living like we're in Los Angeles or something like that. See how the colder air just kind of lingers down there? Only 2 ways to get rid of this inversion. Either the sun warms it up, or you get some mixing with an actual weather system moving through. And notice the temperature inversion is gone and cleaner air is on the way. That's what we're forecasting to happen later this week. Yeah, thanks, Rich. Yeah, we're going to talk about what a temperature inversion is. We're actually going to demonstrate.
Okay, that is now our temperature inversion, and you saw a very nice video to illustrate that, illustrated to you this warm air and cold air. Now we're going to refer to a term that's called the thermal belt. And here we're also going to look at the definition and the development. What is the thermal belt? What are the definition? What is the definition of a thermal belt? It's a layer of warm air found halfway up a valley as a result of temperature inversion. Now you can see how your previous knowledge is coming in again. The cold air is found below the temperature inversion. It's a layer of warm air. Where is this layer? It's halfway up the valley. Why is it there? Because of a temperature inversion. The cold air is below the temperature inversion. Okay, let's see. There's my valley. Very important. It's night. That's my symbol. And how do I know it's night? Then at night, my cold katabatic winds subside into the valley. There's my cold air at night. The warmer air at the bottom of the valley is forced to rise. There is my warmer air that's forced to rise. And this forms a warm thermal belt halfway up the valley. And there is the thermal belt. This cold air collects at the bottom of the valley here to form a frost pocket, which we will see later on. Okay, so this area here is the thermal belt. How does it develop? If there are any pollution that the anabatic wind did not clear, Then it stays in the valley and is not blown out. The katabatic winds flowing at night, also brings cooler or even colder temperatures into a valley at night. This katabatic winds create a thermal belt, which is the horizontal area of warmer temperatures above the valley floor, and it creates a frost pocket. What is a frost pocket? An area of cold temperatures on the valley floor. The thermal belt forms due to the temperature inversion. Okay, inversion condition. Here is a photo of a valley. Now let's see what's going to happen in this valley. Air on the slope at night, you can see that it starts getting later during the day, it starts getting darker now. Air on the slope cools. The cold air, what does cold air do? Cold air sinks to the valley floor. There it happens. There's my cold air, sinks to the valley floor. And now at the valley floor, I might have a factory or an industry. And that cold air is forcing that warm air to start rising. My warm air rises, and at the moment that it starts rising, it's night, at that stage, that warm air will cool down and it will sink again to the valley floor. Okay. Another diagram just to show you the inversion layer. This is my valley. Down in the valley, I have an industry or a factory, and that factory produces polluted air. Now, this inversion layer is trapping that polluted air down here in the valley, and my inversion layer is there on the middle of the slope. Now, if I take a cross section, I have my decreasing in temperatures here. I have my altitude there, temperature here. Normally, as I go higher up the mountain, the temperature drops. Then I reach the inversion layer where the opposite takes place. My temperature increases with height instead of decreasing, and then it follows again. This area here, I have my cold air again. Okay, what is a frost pocket? The definition and development of a frost pocket. A frost pocket is the area of cold air reaching dew point temperature below freezing, and it occurs at the bottom of the valley. So, I repeat again, it's the area of cold air, That cold will reach a dew point temperature which is below freezing, below 0 degrees. And this occurs at the bottom of the valley. It may occur on clear, calm, winter evenings, is when my frost pocket will develop. You can remember we saw this video. There's the frost pocket. It's at night. My air cools down. It flows down the valley. It gathers here in the valley. This cold air forces this warm air to rise, and I have my inversion layer. Now, here's the frost pocket at the bottom of the valley. This influences human activity. The cold air moves down the slope and it collects in the bottom part of the valley. If the air temperature drops below freezing point, dew point is reached, the water vapor condenses into ice crystals, and that is forming frost at the bottom of the valley. The frost on the valley floor where cold air collects is called frost. And I'm going to show you later how this can influence human activity, forming a frost pocket. Then we come to another term, which is radiation fog. And here you also need to know the definition and the development of radiation fog. What is radiation fog? It's fog that forms at night. This is the first important word. It forms at night. How must the area be? It must be clear, calm conditions, which means no winds at all. At night, the sky is clear. Remember, we say clear. Clear means no clouds. The ground surface cools down by radiation loss. Most moisture air cools close to its dew point temperature, and radiation fog occurs below the inversion layer. Why? Because the air is trapped by this layer. So, radiation fog forms at night when there are no winds, no clouds. That is in that specific area. Now, there's that, how it forms. It is, I have the surface here, it's night, the air cools down, there's no wind. The air that cools down reach dew point temperature, and I will have fog that's forming in that area. Development at the bottom of the valley at night, there's a deep layer of cold air where the temperature is below dew point. The water vapor that are found close to the surface condenses around the nuclei in the cold air layer. The droplets of water are suspended in the air, and it forms a radiation fog. It looks like a cloud that forms over the area. In the morning, however, when we have the sun that's shining, the rays will penetrate the fog and it will heat up the surface of the valley again. The warm air will rise as the land and evaporate the fog from the bottom upwards. And then eventually this fog will appear to live. Okay, let's look at a typical exam question on this diagram again. And I have 3 questions for you. Does wind B occur during the day or night? Then we want you to match the type of precipitation. Remember, radiation fog and frost are parts of precipitation. So you're going to read A and B, and you're going to decide whether it's radiation fog or frost. And then number 3, how does wind B? How is it possible that B will form an inversion in the valley? For this question, I'm going to give you 2 minutes. Okay, boys and girls, does wind B occur during the day or the night? And match the type of precipitation, radiation, fog, and frost with the statements below formed when dew point the temperature drops below freezing point, or formed when temperature drops below dew point in the lower section of the valley. And how does wind B create an inversion layer? Let's look at the answers. It occurs at night. For that one, you can get 1 mark. Then 1.4.2. A is frost and B is radiation fog. If it's below freezing point, we always say it is frost. And then question 1.3. When wind B is cold air that is heavy and drains into the valley floor, how do we know it? This arrow tells us that this air is sinking, and it's only cold air that sinks and drains onto the valley floor. This cold air converges on the valley floor and it displaces the warm air. So the warm air that was here is now going to replace this because cold air is heavier than warm air. It displaces the warm air in the valley and it causes it to rise. The warm air causes an inversion in temperature with height, which is an inversion. And here you can see any two. You always write 3 or more than 2 options so that the marker can always see that you have tried and that there's more than 2 options for them to mark. Okay, I think and I believe and I trust that it went well with you. Now, boys and girls, now that I have radiation, fog, slope, valley, anabatic, and katabatic winds, what is the impact that humans can have on this, or the impact that these katabatic winds will have on human activities? Okay, first of all, we look at human settlement. People in South Africa, and South Africa is part of the Southern Hemisphere. People in South Africa prefer warmer north-facing slopes rather than cold, shallow, south-facing slopes. So people will prefer to stay on a north-facing slope as it is warmer. They develop, settlements tend to develop in the mid-slopes. Why? The middle of the slope is where my warm thermal belt is located. The thermal belt again is the warm layer that is trapped above the colder valley floor and beneath the colder mountain top. My nighttime temperatures is higher in the thermal belt. That's why people prefer to live there. At densely settled narrow valleys where the industry is concentrated, air pollution can become very dangerous when pollution and smoke is trapped by the inversion layer. So people will prefer not to stay there. A pollution plume usually can be seen over the affected area, and we'll come back to that pollution plume later during this lesson. It affects people's health, especially but referred to this air pollution that takes place here. People will have respiratory illnesses. Okay, now if I take all the options I gave you, what of them are economic, what are social, and what will be environmental? Okay, if I look at the fact that people prefer to stay on the warm north-facing slope, it is social, it can be social, but it's also economic. Why? Because if you want to purchase a house, it's more expensive to buy a house that is on a north-facing slope because it will be more popular to live there. My settlements will be a social factor. It talks about people, it's social. The air pollution that we have there, air pollution will be an environmental impact. And then people's health will be a social impact. Okay, farming, the effect that this has in farming. In South Africa, the vineyards are planted on my warmer north-facing slope as they require that type of temperature. But trees, shrubs, and shade-loving plants like ferns will thrive on wet, cooler, south-facing slope in the southern hemisphere. So I have my plantations and my ferns, all those plants, they prefer wet, cooler temperatures. So they will grow on the south-facing slope. The indigenous farmers plant their trees in the bottom of the valleys where they require a because they are genetically determined amount of cold weather to set fruit. Citrus fruit cannot tolerate frost, so they are planted against the slope. Forming frost pockets can damage your vegetation and your crops. For example, you won't plant your tomatoes in the bottom of a valley. Farmers will plant frost-resistant crops in the bottom of the valley. Now, this will determine the economic effect of this will be that the better the temperature is, the more the farmer can plant and the higher his income will be at the end. Let's look at another question. And here is my high order question, a paragraph that you must write, and here you can get 8 marks. In a paragraph of approximately 8 lines, outline the negative impact of these forms of precipitation on humans. Now, first, let us see, and we take this question and we take it apart. What is the word? I've got outline. Outline is the verb. That is what is expected from you. What does you do when they ask you to outline? You must give a summary using main points, and you must leave out minor details. So you must just give a summary with main points of what? The negative impact of these forms of precipitation, which is radiation, fog, or frost on humans. With this one, I'm going to help you. Now, first we have to refer to radiation fog. So I will have a heading that says radiation fog. It will affect the visibility for motorists and other activities. If I have this radiation fog, it's like a thick cloud that is in front of you where you cannot see through. So it will affect the visibility for motorists, and that can cause accidents. It will slow traffic, and people might come for late because now eventually they have to drive slower. And the economic impact of that is they will have higher fuel costs. Remember, we must refer to the effect that it has on humans. There's the risk of accidents that will increase as people cannot see each other clearly. You will have a constant dampness, which might or creates uncomfortable conditions for people. And it combines with pollutants to form smoke, which causes health issues. So these are all factors of effects of radiation fog on the human, a negative impact. that this will have on humans. Now, if we go further on and we look at frost, again we have to outline what will be the negative impact of frost on humans. First of all, farmers will only be able to plant frost-resistant crops. We would want to motivate you to use the word frost-resistant crops on the valley. For it's difficult to live in the valley because those temperatures are very low. For frost, temperatures drop below freezing point. Then it's more expensive because it will require artificial heating. So if you live there, it becomes very cold. You will start with ways of heating stuff, heaters, which will take electricity again. Eh? People can fall ill due to cold conditions, and there will be a reduction in income as farming activities are reduced if they don't plant the correct crop. Now, if you get an answer like this, you will see that there are more than one option. The examiner and the marker wants any four. In this case, they accept if you write any more than frost. Most of the time, you have to have half of your answers on frost and half of the answers must be on radiation fog. You have to cover both when you answer a question on this. Okay, let's look at the typical exam question on katabatic wind. And there are my questions. Does the wind occur during the day or at night? This is my wind. What role does terrestrial radiation play in the formation of katabatic winds? Why are katabatic winds associated with temperature inversions? And then 114, we ask you to account for the position of the radiation fog. So what does account mean? To answer for or to explain the causes and why. Okay. With reference to the picture in figure 1.4, explain why a developer is more likely to build a holiday resort halfway up the valley slope. Okay, for this one, I'm going to give you 2 minutes. Quickly write down the answers that you think of that we can use for question 1 to 5. And then after that, we're going to see how did it go with you when answering these questions. Okay, boys and girls, let's see how did it go with you. Does the wind occur during the day or during the night? And it is night. Why? Because this air blows down the valley. Next. Okay. Terrestrial radiation, which results in the cooling of the surface, they want you to use the word terrestrial radiation. The cold surface of the valley slope is required to cool down the air, which develops a cold downslope wind at night. Why? Because of the valley slopes that cool down. The cool air on the cooled surface gets heavy or dense. It rolls down the slope natural under gravity. That's why it goes down. And it's also because I have a high pressure here at the top and I have a low pressure. The air moves from high to low. Yeah, any one of these will give you 2 marks. But remember, you must write a sentence for that. Then the cool air descends onto the valley floor and forces the warm air to rise. The rising warm air rests on top of the cold air. This results in an increase in temperature with height. And then the last question is the atmosphere in the lower section of the valley cools down below dew point temperature. The condensation occurs in the lower section of the valley, and I have small visible droplets from the radiation fog in the lower part of the valley. And here you have to list 2 facts that will give you 2 marks each, and you have 4 marks. Okay. The last one is the settlement will be above the radiation fog. Why are they on the middle slope? There won't be any dampness in that area. I will have an unobscured view of the valley. I'm situated in the warm thermal belt, and that area receives maximum insulation. Again, you can see there are more than 2 options. Always write down more than what is expected from you, so that there's more options for the marker to mark. Okay, now we come to urban climate. Climates in urban areas. Now, in urban climates, a type of a mind map for the urban climate are the reasons for the difference between rural and urban climates. We're going to look at an urban heat island. What is everything that you need to know about the urban heat island? You need to know the definition, the causes of the urban heat island, the effect of the urban island, and strategies to reduce it. So it's definition, causes, effects, and strategies. Then we're going to look at the pollution dome, and with a pollution dome, we look at the definition, the causes, the effects, and strategies. So with a pollution dome and with the urban heat island, you need to know definitions in both, causes in both, effects of both, and strategies in both cases. Okay, so this is your mind map for urban climate. Now, let's look at the reasons. Why is there different? Why are there differences between rural and urban climate? Now, here is my rural area. What do I have? What can you see in this diagram? Firstly, I see there's a road, but what about that road? It's a natural surface. If you look there, it's brown, which tells you it is soil. It's a natural surface. There I have less pollution in there. In the rural areas, I have a few or no industries in the rural areas. Then I have very dense vegetation. You can almost see that the whole diagram is green. And it shows me there's lots of vegetation and there are less people that's living there with few cars. In this specific photo, I see more or less 4 houses, which means there's a few people that's living there. I also have a small heat absorbing surfaces. Due to all the vegetation in this specific area, the area that's absorbing heat is much smaller than it is in urban areas. Okay. Now I've got my urban area. Compared to this, I have urban areas. So what is causing the heat in the urban area? First of all, I have artificial surfaces. Those artificial surfaces consist of tar roads, cement, or paving, or all those types of surfaces that was being built by humans. My buildings are very high. I have high-rise buildings, as you can see in that specific diagram. All those, or most of those surfaces have air conditioners. Now, an air conditioner cools down the inside of the building, but the air that comes outside is warm, and those air conditioners can warm the air over the urban areas. Over my urban areas, I also have lots of industries, factories. They create smoke, which can heat up the city area. We have large dark surfaces, and the roads that's built up of tar is black, and it absorbs heat. I sometimes also have buildings that are painted black, dark colors. I have pollution that is being created by the industries that will increase temperatures over areas. Then in all urban areas, we have many cars, and those cars are producing air pollution, and that air that comes out there is warm. Then we have lots of people living in an urban area. There's a lack of vegetation. If you look at that photo compared to the previous photo, you will see there's only a few trees there, not like the previous slide where there is lots of vegetation. Now, the heat over the city will create an urban heat island. What is the definition of the urban heat island? It is when the city has warmer temperatures than the surrounding rural areas. So it's warmer over the city than it is over the rural areas. If I take this diagram, you will see on this axis I have temperatures. My temperatures at the bottom will be low, there it is high, and here on this area I have the city with the CBD in the middle. I have an urban area here, there I have a commercial area, here is a park, there's a suburb where people live, and there on the outskirts is my rural area. So as I move from the rural areas, I go closer to the CBD, my temperatures increases. You can see how high this temperature is here. Then as I go out, it drops here at the park, it's a little bit lower, but then there over the suburb, it decreases again. So here you can see this area over the urban area is now the warmer area. That's where my temperatures is higher. So it looks like an island in the urban areas due to heat. The causes or the factors, what is causing this higher temperatures over the urban area? First of all, we have building materials. Buildings and structures in the CBD consist of concrete, tar and brick, and those things absorb heat. My tall buildings trap the heat in the city area so that heat that is produced by cars, for example, cannot get out. Air pollution from factories and motor vehicles also trap the heat inside the urban area. In some cases, people are burning fossil fuels which will create higher temperatures. We have a huge amount of cars due to the huge population number in urban areas. And then many industries will release heat. And then we also have central heating from shops and offices, which will create high temperatures. And then at the end, the large concentration of people in the urban areas will also create higher temperatures. What is the effect of the urban heat island? Again, what is the economic effect, the social and the environmental effect of an urban heat island? First of all, if we have these high temperatures, it will cause human discomfort. People will start getting, oh, it's very, very, very hot, so it's discomfort. And that will contribute to a social factor. If it can have an effect on heat stress, people can also die because of this heat stress, this discomfort and this high temperatures that get very hot, and that will be a social factor. Then if we have greenhouse gases, many greenhouse gases will release, which is bad for the environment, and that is an environmental factor then. The increased smog concentration over the cities is also bad for the environment, so it's an environmental factor. The pollution that we will have will reduce visibility, and that will be an environmental and a social impact. And the urban heat island will cause an increase in the use of energy in summer, and that is an economic factor. And the pollution levels which will increase is social and environmental. Now, compared to the urban heat island, we have a pollution dome. And now, later on, I'm going to combine the strategies for the urban heat island and the pollution dome. What is a pollution dome? It is a dome-shaped concentration of polluted air above the city, about the center of the city or the industrial area. The air is trapped by the inversion layer. And this now here you can see this is the dome shape that the definition is referred to. It's a dome-shaped concentration of polluted air. So this whole area here is pollution. The causes of the pollution dome is again air pollution that's caused by industries in urban areas. Also air pollution by domestic fires made by people in urban areas. We see that on many occasions. The car's exhaust fumes due to too many people that are driving cars in urban areas, and then the burning of fossil fuels and the inversion which traps the polluted air. What are the effects of pollution dome? Again, we refer to economic, social, and environmental. The effect of a pollution is that it blocks insulation during the day, and that is the environmental factor. Then we will have precipitation will increase. Why? Because these pollutants act as condensation nuclei, and that's environmental. This pollution, we will have water vapor that forms around these pollution particles, and it will create condensation. It triggers allergic reactions, breathing difficulties, and asthma attacks, which is social factors. It can lead to lead poisoning from all the petrol fumes, which is a social factor. It will cause a smog, which will reduce visibility, and that is a social and environmental factor. And that global climate change will affect the environment. How can we, for strategies that we can use to reduce the urban heat island and the pollution dome, and it's here where a high order question comes in. We can design energy saving strategies like advertising campaigns, encourage people to reduce pollution. We can have green belt areas in urban areas. Green belt areas are parks and trees, planting vegetation in specific areas in the urban area. We can encourage the idea of roof gardens, have roof gardens in the buildings. Encourage the use of public transport, therefore making your public transport more affordable. Encourage people so that there are less cars on the road. The use of light-colored materials, shade parking areas in urban areas, and then there's also videos that you can watch that can give you ideas of how they do that. Now, here is an extract that's based on urban heat islands. City dwellings are burning the burn of extreme temperatures. It's a case study with questions on it. Define the concept urban heat island, which we look at. Give 2 quotations from the extract where you have to go back to the extract to get 2 quotations from that suggest that poor planning is responsible for increasing temperatures in cities. Why is the urban heat island effect more concentrated at night? And then in a paragraph of approximately 8 lines, provide sustainable green strategies that can reduce the heat island. So if we look at that, we'll quickly look at the answers. What is the urban heat island? It's the area of high temperatures over the city that decreases towards the rural area, or a phenomenon that makes urban areas hotter than the surroundings. The second question is when you have to make a quote from the passage. There are a lot of quotes. You only have to mention 2. The global focus of city infrastructure planning has been on cars, getting as many people as possible into tall buildings, etc. And then the third question's answer, subsiding air at night pushes the warm air closer to the buildings in the city, which will result in more heat concentrated. Weaker convection currents at night concentrates the heat island, and the subsiding air traps the heat between the buildings. And the last question is on the paragraph that you need to write, and there's a lot of strategies that I can use to reduce the. Or you have to choose. Thank you, boys and girls, for this presentation. Use this presentation afterwards. It's recorded, and see if you can answer these questions without looking at the answer. Good luck with this part of the climatology section. It's a part where you know the basics, you can score a lot of marks.